We're looking at how do I represent the solution to a system of inequalities. An inequality is different from an equation. It has a less than or greater than symbol, less than or equal to, greater than or equal to symbol. Instead of having just a point of intersection, it has a whole region of the coordinate plane that intersects and overlaps another region of the coordinate plane, and that represents the solution region. The solution must work for all inequalities. Very similar to an equation, the solution must work for all of the equations in the system. Remember, when do you flip the sign when you're solving an inequality? When you multiply or divide both sides by a negative number. Let's look at some examples. Example 1, decide if the points listed below are a solution to the system of inequalities. Take a minute and substitute into both of the inequalities to see if you get a true statement. So you can see where I have substituted into the first inequality, and when doing that you get negative 8 is less than or equal to 9, and that is a true statement. Then I substituted into the second inequality, 2 for x and 0 for y, and you get 12 is greater than 12. 12 is not greater than 12. That is not a true statement. Therefore, this point is not a solution to the given system of inequalities. Looking at the second ordered pair with an x value of 3 and a y value of negative 1, when you substitute into the first inequality, you get negative 13 is less than or equal to negative 9, Negative 13 is less than 9, so that is a true statement. When you substitute into the second inequality, you get 20 is greater than 12. That is also a true statement. So B, 3, negative 1, is a solution to the system of inequalities. Now we're going to look at finding the solution region by graphing. You really only graph a system of inequalities to determine the solution region. So for example 2, you're going to start off by graphing these two lines that are in slope-intercept form. Think about from the beginning whether you should use a dashed or a solid line. The first one is a dashed line, the second one is a solid line. So the first one, y is less than 3x minus 1. I'm going to use slope-intercept form to graph the line. And then I'm going to dash the line, indicating that points on the line are not solutions. Now if we pick a point that is not on the line, like 4, 0. If we substitute for 0, we would get 0 is less than 3 times 4 minus 1. 0 is less than 12 minus 1. 0 is less than 11. So the points on this side of the line are solutions. So I'm going to leave it like that for right now. I'm not going to shade. I'm just going to indicate that the points on this side of the line are solutions. Again, I just tested a point to see that this point is a solution, so all the points on this side of the line are solutions. Now let's graph the second line. Y is greater than or equal to 1/2 x plus 3. So use the slope and the y-intercept of 3, slope of 1/2. This is greater than or equal to, so I'm going to do a solid line. 0, 0 for this one is clearly below the line, and 0 greater than or equal to 1/2 times 0 plus 3. 0 greater than 3. No, it is not. So then we know that we would shade above this line. So where would the two solution regions overlap? If we shade all the way over here, this whole side of the graph would be shaded for the blue line, but only this part would be shaded above for the red line. So the solution region lies in between, above the red line and below the blue line. Points on the red line are solutions. Points on the dashed blue line are not solutions. So I could pick a point like 4, 5 and say that's a possible solution. I could also plug it into both of the inequalities and make sure it works. 5 is less than 12 minus 1. That's a true statement. 5 is greater than or equal to half of 4 is 2. 2 plus 3 is 5. 5 is equal to 5. And since we have greater than or equal to, that's a true statement. And then anything not in that highlighted region would be a possible non-solution, like 0, 0. So again, we only want to shade the region that represents the overlapping shaded regions, the two regions that overlap when you graph the two inequalities on the same coordinate plane. So for example, 3, they're not always in slope-intercept form, so start off by putting these two lines in slope-intercept form. For the first one, 12y is greater than, add 4x, divide both sides by 12. Y is greater than 1/3, 4 over 12, 1/3, plus 36 divided by 12 is 3. So when we graph that, we have a y-intercept of 3 and a slope of positive 1/3. And this is a dashed line because we do not have equals in the symbol. It's only greater than. 0 greater than 3 is not a true statement. 0, 0 is not a solution. Therefore, this line would be shaded above. Now when I take the second line and add 8x, 24y is less than 8x minus 48. Divide by 24. Y is less than, again we have 1/3 here, x minus 2. So minus 2 and a slope of 1/3. And again we have no equals in the symbol, so we're going to dash the line indicating that points on the line are not solutions. 0, 0. 0 is less than negative 2 is a false statement, so 0, 0 is not a solution, so this line would be shaded this way. Here we have an example of parallel lines, and the solution region is opposite. One is shaded above, the other was shaded below. So where will these shaded regions overlap? They will not overlap. Therefore, there is no possible solution. Non-solutions, all ordered pairs, all xy ordered pairs would not be solutions. There is no solution to this system of inequalities because the shaded region does not overlap. Okay, one more example. I did put some notes for us at the bottom to help us with our x only and our y only. HOY, H-O-Y, stands for a horizontal line with a 0 slope, has an equation with y only. So y equals 3, crosses the y-axis at 3, and it's a horizontal line with a 0 slope. It is y is less than or equal to 3, so I used a solid line for that one, and less than would be shaded below the line. If I was graphing the x only, I could use VUX, vertical, undefined slope, x only. So x only is a vertical line crossing at -2. This is greater than only, so we're going to do a dashed line at -2. And greater than would be shaded to the right of the line. So right now we would have below the horizontal line and to the right of the vertical line. Now let's graph the last inequality. And again, this was a dashed line up here. And for the last inequality, it'll also be a dashed line. We're going to add 3x to both sides. And then we're going to divide by 2. We do not need to flip the symbols because we did not divide by a negative. So y is greater than 3 over 2x minus 3. So I'm going to start at -3, go up 3 over 2 for my slope. And I'm going to draw a dashed line. Again, a dashed line indicates that the points on the line are not solutions. 0, 0 is above this line, so when we test 0, 0, when we use 0, 0 as a test point, 0 is not greater than -3. Oh wait, yes, 0 is greater than -3. 0, 0 is a solution, so we would shade this direction of the blue line. So now look to see where those shaded regions overlap. Below the black, to the right of the red, and above the blue line. So my solution region is this small triangle that I'm highlighting right now. So the final shaded region represents where the 3 shaded regions overlap. That's my final solution region. So a possible solution here could be 0, 0, 0, 1, 1, 1, 1, 2, -1, 1. Be sure I don't get anything on these dashed lines. 0, -1, -1, -1. All of these points in here in this highlighted region would be solutions. Non-solutions, a point on the dashed line, like 2, 0. That is not a solution because it falls on a dashed line. -2, 0, -2 anything. -2 anything would not be a solution because you wouldn't have an x value greater than -2. So in summary, here are some notes that will help you remember horizontal, vertical, 0 undefined, y only, x only, and some acronyms that you can use for that. And then solving systems of inequalities is done graphically by determining where the shaded regions overlap. Now complete the practice problems in your homework section.